In this video, I will explain to you about assignment that I gave you before. For number 1, there is about the resultant force. In the resultant force, you just need to add all of the force that exert on an object. Okay, so remember that right direction and up direction, that's mean positive. Left and down direction is negative. So for number 1, there is 80 to the right and 45 to the left. Therefore, we will have resultant force 80 Newton plus negative 45 Newton. So the resultant force is 35 Newtons. Okay, that is positive. That means we will have the right direction. So we'll draw in here 35 Newton. Same like number 1. We have 60 Newton to the right, and then we have 50 Newton to the left. That means we'll have negative 50 Newton plus negative 40 Newton. Okay, so we will have negative 30 Newton. Because there is negative, that means it's to the left. To the left direction. So we will draw like this. Yeah. Okay. So next, the third. In number 3, we have two dimension, x-axis, the horizontal one, and y-axis, the vertical one. So we just calculate the horizontal and vertical separately. So for the horizontal one, horizontal usually we use x because horizontal is x-axis. There is 20 Newton plus negative 20 Newton. Yeah. So the total is 0 Newton. For the y-axis, we have, remember, up is positive. So that means 20 Newton plus negative 40 Newton. So the total is negative 20 Newton. Yeah, if we find the resultant force is 0, that means there is no arrow from or to the object. But here, the y-axis, we have negative 20 Newton. That means this one is go down. The direction is go down. And for the number 1, actually, this is go right. Yeah, because there is go down, we draw like this. 20 Newton. Yeah, we don't need to draw the horizontal one because the total is 0 Newton. Okay, for number 5, yeah, just like before, 100 Newton plus negative 100 Newton. Equal with 0 Newton. So there is no arrow in horizontal axis. And then for y resultant force, there is 20 Newton plus 40 Newton plus negative 100 Newton. So the total is negative 40 Newton. So this one is go down. Then we just draw like this, 40 Newton. Remember, horizontal and vertical, we cannot mix them together. Okay, we need to calculate them separately. That's for number 1. Okay, this part I will explain about the number 2. Okay, there is a picture in here, and for number 1, 2 of the force that have effect that cancel each other out. This means the one that have zero resultant force. Okay, so first one, just like the number 1, yeah, we can just simplify this picture. Okay, so we can say the lorry is like this one box, and we have 1200 Newton to the right, and we have 1300 Newton to the left, 5000 Newton down, and 5000 Newton up. Okay, so just like the number 1, first we search for X resultant force. We have 1200 Newton to the right plus 1300 Newton to the left. So total is negative 100 Newton, or go left. Then for Y resultant force, we have 5000 go up and 5000 go down. So that means the total is 0 Newton. So for first question, which two that cancel each other out, that means the force that go down and go up, or you can say that the vertical force. Why? Because they have zero resultant force. B. What is the resultant force acting on the rolling? Give it magnitude and direction. We already calculated, so this one. The resultant force is 100 Newton to the left magnitude, and this one is the direction. C. What effect will this resultant force have on the speed at which the lorry is traveling? Remember the Newton's second law? We have a resultant force. That means the speed at which the lorry is traveling is accelerate. The lorry will accelerate. D. If the lorry mass is 6,000 kg, what is the lorry acceleration? Just like the Newton's second law, acceleration is force divided by mass. So the force is 100 Newton per 6,000 kilogram. So the acceleration is 0.0167 meter per second square. That's for the number 2. Next is number 3. It's about the momentum of an object. So there is a 2000 kilogram car with the velocity is 30 meter per second, and there is a 4000 kilogram truck in the front of the car that move at 10 meter per second. So first one is to calculate the momentum of car and the momentum of truck. So we know the formula. Is it the momentum equal with mass times velocity? So from the question, we will have the data is the mass of the car, 2000 kilogram. Velocity of the car is 30 meter per second. Mass of the truck is 4000 kilogram. And velocity of the truck is 10 meter per second. And for question A, the momentum of the car is equal mass of the car times velocity of the car. It's equal with 2000 times 30 meter per second. So it's equal with 60,000 kilogram meter per second. This is the momentum of the car. And the momentum of the truck is truck mass times truck velocity is 4000 kilogram times 10 meter per second. So the momentum of the truck equal 40,000 kilogram meter per second. So this is the momentum of the car and momentum of the truck. And then for question B, if the car hit behind of the truck, then the truck velocity become 15 meter per second. Calculate the car's velocity after collision. So we can assume that car and truck have same direction. Yeah. So this is the car and this is the truck. They have same direction. This is before the collision. The velocity is 30 meter per second and the velocity of the truck is 10 meter per second. And then after car hits the truck, the velocity of the truck after collision is 15 meter per second. This is the after. And we need to calculate the velocity of the car after collision. For this one, we have another data. Let's see. We can add this one as first or before collision. And we have one new data that truck velocity after collision is 15 meter per second. Okay. And the formula for the conservation of momentum before collision equal with momentum after collision. Momentum before collision is the momentum of the car, plus momentum of the truck. And after collision is same. But we put this one is 2, so we know that after collision. Next, this one is mass car times velocity of the car before collision. Mass of truck times velocity of the truck before collision. Mass of the car and velocity of the car after collision. Mass of the truck times velocity of the truck after collision. So we just need to put in the data. So velocity of the car after collision is 40,000 per 2,000 equal 20 meter per second. So there is a positive one, so that means after collision the car still move forward. Okay, that's for the number 3. For the last number, actually this is same with the number 3. You can just read the question and we will have the data is there is a toy engine or moving engine and stationary truck. So the mass of the engine is 0.5 kilogram and the velocity of the engine is 0.4 meter per second. And there is a stationary truck. Stationary truck means the velocity is 0. And the mass of truck is 0.3 kilogram. And the velocity of the truck is 0 meter per second. This is a velocity before collision. And then first is a question. Calculate the momentum of toy engine before the collision. So that means we just need to calculate the toy engine only. Momentum of the engine is mass engine times velocity of the engine before collision. 0.5 kilogram times 0.4 mass per second. It's equal with, this one is before collision, 0.2 kilogram meter per second. This one is the momentum of the toy engine before collision. Next is B. Using the principle of the conservation of momentum, calculate the speed of the joined engine and truck immediately after the collision. That means engine and the truck is joined, they become one. So the mass of the engine and the truck, we can just add the total mass. So the total mass after collision, we can just write like this. So the momentum before collision is and momentum after. Momentum before collision is engine plus momentum of the truck. equal with momentum of the engine and the truck, because they become one, they join. So this one is, we already know the answer, 0.2 plus this one is the momentum of the truck before collision. So before collision, the truck have zero momentum, equal with this one is mass of engine and the truck times velocity of the engine and the truck. So there need to be 0.2. This one is 0.5 plus 0.3 times the velocity. 0.2 equals 0.8 times velocity engine and truck. So that means the velocity of the engine and the truck is 0.2 per 0.8. This is 0.25 meter per second. So this is the final answer. Okay, that's the explanation of the assignment that I gave you before, and goodbye.